coefficient of variation. So it's another measure of spread. Since the standard deviation is meaningless without the mean, with the coefficient of variation, what we do is we take the standard deviation, divide by the mean, so it's a measure of the standard deviation as a percent of the mean. And here's an example to think about it. So let's say I gave a quiz in my class and the average spread was 1. I gave a test in my class and the average spread was 1. Now, usually with a quiz, it's only worth like 10 points, and a test is worth 100 points. So here I have my quiz scores, and the average grade for quiz scores was about a 7, but the average spread for quiz scores was a 1. Okay. So the spread as a percent of the center, so that's 1 out of 7, that's about a 14% spread here. So it's a pretty big spread for that 7. So people got, a score. Some people scored a 5, some people a 6, 7, 8, and a 9. Now I gave a test and the average spread was 1. But the average grade on the test was 70%. And some people got 71%, and some people got a 72%, some people got a 69, 9, and some people got a 68. But still, the average spread is a 1, right? The standard deviation here. 1 out of 70 is 1.43%. So the spread compared to the center is 1%. The spread compared to the center over here for the quizzes is 14%. Right? So you can't compare the standard deviation of two samples or two populations unless you compare the means also. If they don't have the same mean, the standard deviations are not directly comparable. So this is important. So if samples or populations have different means, then their standard deviations are not comparable. So that's why we need the coefficient of variation. So we'll just take a look at another example, a couple more. All right, so the birth weight example, which I've brought up before and you'll probably see again, I sorted them here by females and males. So the average female weight was 3,138.7 grams. The average male weight, let's blow that up a little more, 3,257.6 grams. So on average, the males were a little bit heavier than the females, but not that much. As far as the spread, the males had maybe a larger spread on average than the females, but I can't really say, compare the STTs directly because they don't have the same means. So what we have to do is we have to take the STD, divide by the mean, and that gives us coefficient of variation. So this spread compared to the center, we have about a 18.9, 19% spread. The average spread compared to the center for the males is about 20%. So it looks like even though the males have a larger STD, they also have a larger mean. It turns out they still have a larger percent spread. And we can't really compare, again, the STDs, standard deviations, unless the means are the same. Now, they are actually pretty close. They're not that far off. We're off by what? 80 grams, which isn't a lot out of 3,000. So the means are pretty darn close, but the STTs do seem a bit apart here, and the coefficient of variation says, yeah, they are just a little bit apart there. Notice also here that the mean is less than the median for both the males and the females, and that's because the left skew, these lower weights, pull the mean away from the median as far as the measure of center goes. Another example. I collected some data from new students in most of my classes, and I asked questions about, how much do you text, how much do you watch TV, and a whole bunch of other things. Here I picked on the average number of texts, chats, posts, or calls a person has each day, and I have it organized by female and male data. And notice I have a lot more female students in my classes than males for some reason. The average number of texts, chats, posts, calls each day for males was quite a bit higher than the females. Males also had a much larger spread, it appears, from the STD. However, when we look at the STD compared to the mean, the females have a larger percent spread. So 46 out of 34 is a bigger spread than 72 out of 57. Notice the 133% of the mean here and 125% of the mean there. So again, coefficient of variation is percent average spread based on the mean. So the standard deviation of 46 is 133% of this mean of 34. Okay. And again, we can't compare STDs, standard deviations, directly on two populations or two samples unless the means match. If they don't match, we have to use the coefficient of variation to make them more comparable. So coefficient of variation is a way to compare spread of two samples or populations that have different means. And it's important in statistics to make those comparisons. Thanks. Have a good day. Do good math. See you soon.